Hello students. So in this section we will discuss about the motion under gravity. That means how an object moves in the influence of gravity. So basically we are going to discuss about the free fall. Just like this, you will observe that there is an object which is dropped from a certain height. So obviously because of the gravitational force, it will do motion under the influence of gravity. So in this section, basically we are going to discuss about this topic, alright. So we will discuss two cases. For example, if an object is dropped from a certain height and if the object is thrown vertically upward but after some time it will come back. So obviously there is acceleration due to gravity. So let's start this topic. Here you will observe that there is a ball, okay? You will observe that there is a ball. Now this ball is thrown vertically upward. So what will happen? This ball will go upward and after some time it will return like this. Okay, so what is happening here? We are going to discuss about this. Basically, when the ball is moving in the upward direction, its velocity is decreasing. Why? Because its motion is upward, but the acceleration due to gravity is downward. That means acceleration is in the opposite direction of its motion. So definitely it is retarded motion and that's why its velocity is decreasing. After reaching the maximum height, its velocity will become 0 and that's why the ball will return. Alright, so this is the case 1 which we are going to discuss and we will discuss about the equations of motion in this also. Now, let's take another case. Here, there is a ball, okay, and this ball is dropped from a certain height like this, okay. So now this ball is just dropped. Maybe it has some velocity at its initial position and maybe its initial velocity is 0, okay. So if it is thrown, then it will have some velocity, initial velocity. But if it is dropped from a certain height, then its initial velocity will be 0. So let's start this section. Free fall, motion under gravity. Basically, we are discussing about the free fall. So, whenever an object moves under the influence of gravity only, then the object is said to be in free fall. So, free fall is the motion of an object subject only to the influence of gravity. An object is in free fall as soon as it is dropped from rest, thrown downward, or thrown upward. That means there are three cases of free fall. If the object is dropped from rest, that means like this, its initial velocity is 0. If the object is thrown downward, that means it is thrown downward but its initial velocity is not 0, it has some value, and it is thrown upward like this. So obviously it will have some initial velocity. After reaching the maximum height, it will return. So these are the three cases. Let's discuss one by one. So here we have to understand acceleration due to gravity first, because we know that when the body is moving under the influence of gravity, there is acceleration due to gravity. So students, the constant acceleration of a freely falling body is called the acceleration due to gravity. Whenever a body is moving under the influence of gravity, there is a fixed value of acceleration that is denoted with the small letter g, okay, and the value of acceleration due to gravity we can take 10 meter per second square or 9.8 meter per second square according to your convenience, according to the numerical value, according to the calculation, right? So equations of motion of freely falling body we are going to discuss when we are taking the case 1, when the object thrown vertically upward and it returns after some time. So what will happen? Let's take here, there is the object. Now it is thrown vertically upward, so it has some velocity, that is u. After reaching the maximum height, this is the maximum height which is denoted with capital H, and this is the small h height. Let's take, this is any random height, okay. So now we are going to discuss about the equations of motion for this case. And here, what is the acceleration? So here acceleration due to gravity is g, which is acting downward. Now, when you will use the sign convention in this, you will find that the upward is positive, downward is negative, this one positive, this one negative. Alright. So here the initial velocity is upward, that means this is positive. Here the displacement is also upward, so this is positive. but acceleration due to gravity is downward, so this will be negative. Firstly, we will find the first equation. So first equation is V is equal to U plus AT, right? This is the first equation. Now in this case, V and U both are in the upward direction. Final velocity will be upward if you will take here or here. The maximum height, the final velocity will become 0, and here it will have some velocity. But it will be positive, so we will write positive V. U is positive plus acceleration is minus g, so we will write here minus g, and time is always positive, so this equation will become V is equal to U minus gt. This is the first equation in this particular case. Okay. Now obviously the ball is moving in the upward direction, so after reaching the maximum height, its final velocity will become 0, and we can calculate the maximum height and this certain height. So how you will find the height? We will use the second equation. So second equation is S is equal to ut plus half at square. Now here if you will take small h, then small h will be ut plus 1 by 2, acceleration is minus g and t square. So it will become h is equal to ut minus half gt square. Alright. Now the third equation. So third equation is V square is equal to U square plus 2AS. Here V is positive, so V square, U is positive, U square plus 2, and A is minus G, S is H, so V square is equal to U square plus minus 2GH. This is the third equation. Alright, so these three are the equations of motion for case 1. Now, in the case 1, time taken to reach maximum height. Now we have to take maximum height. So how you can find the time taken? By using first equation and by using second equation. If you have to find the time taken to reach maximum height, then you can do one thing. You can use first equation, V is equal to U minus gt. But after reaching the maximum height, as I told you, the final velocity will become 0. Okay, so here you will write 0 is equal to U minus gt. So it's U is equal to gt and t will be U upon g. This is the formula of time taken to reach maximum height. Alright, now time of total journey. That means time taken to reach maximum height, and obviously after reaching the maximum height it will return. Again it will take same time to reach ground. So I can say the total time of journey will be twice of time taken to reach maximum height. So it will be 2 into t is u upon g. That means t is equal to 2u by g. This is the formula of total time of journey. Right? Now, this is the second case when the object is dropped from a certain height, or I can say when the object is thrown from a certain height. So when the object will dropped or thrown from a certain height, then obviously it will come to the ground. Now we can take two cases in this. We can take initial velocity is 0 and we can take initial velocity has some value. So let's discuss this case. When this ball will come downward, obviously it will come like this and it will accelerate towards the ground. Now in this case, students, initial velocity is downward. Final velocity is also downward. And here the acceleration due to gravity is also downward. And if you will take any displacement from this position to this position, let's take this is y. And if you will take total displacement, that is h. So obviously both are positive or negative? Obviously both are negative. Okay. So u is negative, v is negative, okay, and y is negative, h is negative, and g is also negative. All are negative because all are downward. So an object is thrown vertically downward from a certain height h. Let's take the object here. This is the object which is thrown from a certain height. So obviously u is negative, g is negative, y is negative, h is negative, okay. And here the final velocity will also negative. Here this is y, which is a particular certain displacement, and this is the total displacement, or we can say total height. So can we find the first equation in this case? Yes. The first equation is v is equal to u plus at, but here v is minus v, u is minus u, plus acceleration is minus g, time is always positive. So minus v is equal to minus v plus minus minus gt. Here you will take minus common. So you will get bracket u plus gt. Minus to minus cancel. V is equal to u plus gt. This is the first equation in this case. Alright. Now we will find the second equation also. This is the first equation. Now we will find second equation. So in second equation you can take y or h. If you want to find out the maximum displacement, total displacement, you will take total height, that is capital H. And if you want to find out the displacement from this position to this position, you can take minus y. So I am taking initially minus y, then I will take minus h. So what is the second equation? Second equation is s is equal to ut plus half at square. So here I will write minus y in place of s. U is minus u, time is positive, plus 1 by 2. Acceleration is minus g and it's t square. So minus y is equal to minus ut plus minus minus 1 by 2 gt square. Now here we can take minus common. So it's ut plus 1 by 2 gt square. Minus to minus cancel, you will get y is equal to ut plus 1 by 2 gt square. This is the second equation. Alright. Now the third equation will become v square is equal to u square plus 2as. Here v is minus v square, u is minus u square, plus 2, a is minus g, and s is minus y we are taking now. So minus v square will be plus v square, minus u square will be plus u square, minus minus will multiply, this will become plus 2gy. So this is the third equation. Alright students, now you can put u is equal to 0 if the object is dropped from a certain height. So let's find out velocity at the ground. If you want to find out the velocity at the ground, then what you will take? You will take maximum displacement. So how you can find velocity at the ground? So students, you can use third equation, v square is equal to u square plus 2g. Now we will not take y, we will take capital H. So v will be root of u square plus 2gh. Alright. And here, if u is equal to 0, so when you will put u is equal to 0, so you will get root of 0 square 0, 0 plus 2gh. So it's only root of 2gh. This will be the final velocity at the ground. Alright. Now, time taken to reach the ground and time taken to reach the ground if u is equal to 0. So we can use here first equation, v is equal to u plus gt. Okay. So here time will become v minus u upon g. This is the formula of time. From second equation also you can find out the time. Time taken to reach the ground, that means we will take h is equal to ut plus 1 by 2 gt square. So by using this equation you can find out the time. Now if u is equal to 0, then you have to find time taken to reach the ground. So here you will put u is equal to 0, then you will get the time is equal to v upon g. This is the formula of time. By putting the value of u 0, you will get t is equal to v upon g. Alright students, now we have some questions. So let's solve these questions. These questions are based on the case 1 and case 2. So here is the question. A rock is thrown downward from an unknown height above the ground with an initial speed of 10 meter per second. It strikes the ground 3 seconds later. Find the initial height of the rock above the ground. A 44 meter, B 14 meter, C 75 meter and D 30 meter. So students, here the rock is thrown downward. That means this is the case second. Okay. So the rock is shown downward, and obviously it has some velocity, so we can take initial velocity of rock is 10 meter per second, and let's take this is dropped from a height h. You have to find this height h, and the time taken by the rock to reach the ground is 3 seconds. So can we find out the height? Yes, by using second equation. So second equation is h is equal to ut plus half gt square. This is the second equation. Why we are taking capital H, students? Because we have to find the total height. So h will be u is 10, time is 3 plus 1 by 2. G you can take 10 here and time is 3. So it's 3 square. So h will be 10 into 3, it's 30 plus 2 to 10 will cut 5 times. So 5 into square of 3, it will be 9. So h will be 30 plus 5 into 9, it's 45. 30 plus 45, you will get 75 meter. This is the height. So this is given in option number C. That means your correct answer for this question is option number C, 75 meter. Alright. So this is so simple. Moving on the next question. A stone is dropped from the top of a tower. When it has fallen by 5 meters from the top, another stone is dropped from a point 25 meters below the top. If both stones reach the ground at the same moment, then height of the tower from the ground is, take G is equal to 10 meter per second square. Option A 45 meter, option B 50 meter, option C 60 meter, and option D 65 meter. So this question is very good. Let's start. A stone is dropped from the top of a tower. So let's take a tower here. And height of the tower is h, because we don't know what is the height. So let's take this is h. A stone is dropped from the top of a tower when it has fallen by 5 meters from the top. So this is the top of the tower. Let's take this is the stone which is dropped. So its initial velocity is 0. And after reaching the 5 meter, it will come here. And let's take this is position A and this is position B. Okay. So after reaching this position, obviously it will have some velocity. So let's take this is V. Now, when this stone will reach here, then another stone is dropped from a point 25 meters below the top. So this is the top, and from 25 meters below, that means at this point. Okay. Another stone is dropped. And obviously, because it is dropped, its initial velocity is 0. Now, students, this is stone 1 and this is stone 2. So, obviously, they both will cover some distance. So, at this position and at this position, this is stone 1 and this is stone 2. So, these are reaching the ground at the same time. Okay, they will reach the ground at the same time. So, I can say how much distance is covered by the stone 2. So, it's h minus 25. And how much distance is covered by the stone 1? So, 5 meters it has already covered. So, it's h minus 5. Okay. And time taken to cover h minus 5 by stone 1 and h minus 25 by stone 2 will be same. So, let's find. Now, here the final velocity at point B, that is V, will become initial velocity for this height h minus 5. So, for stone 1, I will find the velocity at point B. So, I will use third equation, V square is equal to U square plus 2G and H here. And because it is dropped, so obviously its initial velocity is 0. So, V square is equal to 0 plus 2G, we have to take 10 and H. So, height is 5 meters right now. So, V square will be 2 into 10, 20, 20 into 5. So, it will become 100. So, V will be root of 100. That means 10 meters per second. That means here the velocity will become 10 meters per second. Now, I am taking only this position and this position. So, let's draw the diagram again. Here the tower is having height h. Now the stone one is here, which is 5 meter below the top. So obviously it will cover the distance which is only h minus 5, and the stone 2 will cover h minus 25, and its initial velocity is 0, and here the velocity of stone 1 is 10 meter per second. So let's apply second equation. So for stone 1, the second equation will be s is equal to ut plus half gt square. So here the distance is h minus 5 is equal to ut. So its initial velocity is 10. You can take this is u for this position. So u is 10 ut plus half, g is 10 and t square. So it will become h minus 5 is equal to 10t. 2 to 10 will cut 5 times. So it's plus 5t square. So here h will come 10t plus 5t square, and this minus 5 will become plus 5. This is equation 1. Now for stone 2. For stone 2, we will apply the same equation, but here the distance covered by the stone 2 is, this is stone 2. So its distance is h minus 25. It is dropped, so its initial velocity is 0. So ut will become 0. So ut plus 1 by 2 gt square. So here h minus 25 is equal to, it's 0, 1 by 2, g is 10 and t square. So 2 to 10 will cut 5 times. So here h will come, minus 25 will come here. It's 5t square plus 25. This is equation 2. Okay. Equation 1 and equation 2. Now from equation 1 and equation 2, height is this. Okay. So we can equate these two equations. So from equation 1 and equation 2, from equation 1 and equation 2, 10t plus 5t square plus 5, 10t plus 5t square plus 5 is equal to 5t square plus 25. Now here 5t square to 5t square will cut. 10t will be this plus 5 will go here. 25 minus 5, it's 20. So t will be 2 seconds. Okay. But what we have to find? We have to find height. So we can put the value of time in equation 2 by getting time, and we will find height. So height will be, in equation 2, t is equal to 2 seconds. We will put, so here equation 2 is this 5t square plus 25. H is equals to 5t square plus 25. So h will be 5. T is 2. So square of 2 plus 25. So h will be 5 into square of 2 is 4 plus 25. So 4 into 5, it's 20. 20 plus 25, it's 45 meter. That means the height of tower is 45 meter. This is given in option number A. That means your correct answer is option number A. Alright students, now go through the content, solve relevant questions. Thank you.